In this video, I would like to introduce you to cylindrical coordinates. So let's start with our familiar Cartesian coordinates. We have three axes that are perpendicular to one another. So we have the x-axis, y-axis, z-axis, and each axis is perpendicular to the other two axes. So if we have a point here in space, it has three coordinates, x, y, z. X is the height of the point above the y-z axis. So if we project this point down onto the xy plane, the length of the projection from here to here, we can see here this is a perpendicular line with this projection. This line here makes a right angle with the y-axis. The distance here is x, and the length of the projection from the point here to the x-axis, this is the y-coordinate, and then the z-coordinate is the height of the point above the xy plane. So the length of this line here is equal to z. So in cylindrical coordinates, instead of x, y, z, we're going to have r, phi, and z. So z is unchanged in cylindrical coordinates. X, y are now, instead of x, y, we're going to have r and phi. So what are r and phi? So if we take the point projected down onto the xy plane, the distance from the origin, this is our origin, coordinates 0 and 0 and 0. So the length, the distance from the origin to the projection of the point on the xy plane, this line here is what we call r. And the angle that this line here makes with the x-axis is called phi. So this r here is the distance of from the origin to the projection of the point down onto the xy plane, this line here. Phi is the angle that that line makes with the x-axis. So how can we convert from one coordinate system to the other? So let's say we want to go from x, y, z to r, phi, and z. So z remains unchanged, so we don't have to worry about it. So what's the relation between r and x and y? So if we look at one of these triangles here, we said this side here is y. The distance from the origin to this point here, well, that's the x coordinate. So let's draw this triangle here outside. So we have a right angle triangle. This side here, y, corresponds to this side. This side here is this side here, which is x. And then r is the hypotenuse. So the relation between x and y is r equals the square root of x squared plus y squared. Now, how about the angle? Well, this is the angle phi. So tan phi equals y over x. So once we know x and y, we can compute r and phi. So that's going from this here, from x, y, z to r, y, r, phi, and z. We have r equals square root of x squared plus y squared. And we have tan phi equals y over x. How about going the other way around? So if you want to go from r, phi, and z to x, y, and z. So again, if you look at this right angle triangle, x equals r cosine theta. So x equals r cosine phi, and y equals r sine phi, and z remains unchanged. So this is how we can convert from the r, phi, and z to the x, y, z Cartesian system.